Hey guys, today we're going to be talking about some mid to upper level SAT geometry problems. So in the figure shown here, a circle is tangent to a line at point P. If the radius of the circle is 5, what is the value of t, the y-intercept of the line? So immediately you're going to want to notice that because this line is tangent to this circle, there are going to be some right angles at play. Let me add that radius in, that's 5 right here. And those right angles are going to be right here and right here. And then you're going to want to notice that because these are tangent, this line is perpendicular to this line. And then in turn, their slopes are going to be opposite reciprocals. So to find the equation of this line, we know that this is 5. And then because of this coordinate, we know that this right here is k. And the height right here is 4. So to find k, we just use Pythagorean theorem, and it comes out equaling 3. So now we know the equation of this line because the y-intercept is 0. Just y equals, and then y is overrun, it's 4 over 3 x. Then because of that, we automatically know what the slope of this line is. It's the opposite reciprocal. So it's y equals negative 3/4 x. And then we don't know the y-intercept. That's what we're trying to find, the t right here. But to find the b, the y-intercept, we can use this coordinate right here, 3, 4. We plug that in for x and y. So we'll get y equals negative 3/4 x, which is the 3, times 3, plus b. Now we'll get common denominators. We'll put 4 as 16 over 4 is equal to negative 3/4 times 3. Oops. That's negative 9/4 plus b. And then when you add negative 9/4 over to this side, you're going to get that the y-intercept is equal to 25/4. This is about a 4 or 5 difficulty level geometry problem on the SAT. Alright guys, so in this next problem we're going to have to use triangle similarities. In the figure right here, ABCD is a rectangle and BM is perpendicular to AC. If the length of AM is 2 and the length of CM is 18, what is the area of ABC, this triangle right here? So to find the area of this triangle, we have everything we need except for x, which is the height of the triangle. So we're going to need to find. And if you examine this problem, you're going to find that I think the only way to solve this problem is to use triangle similarities. And because this triangle is similar to this triangle, we can do that. Now, if you can imagine flipping this triangle on its back, just like making it fall over, making B go to C, M staying where it is, and A going to B, you can see that this x, which is the smallest side of the large triangle, is proportionate to the 2, which is the smallest side of the small triangle. So we'll go x, which is the smallest side of the large triangle, over 2, the smallest side of the small triangle, is equal to, and then we'll go to the next largest side, which is 18 of the large triangle, over the next largest side of the small triangle, which is x. Then you can just cross multiply, and you'll get x squared is equal to 36. Take the square root of each side, and you'll get that x is equal to 6. And now that we have the height of this, we can find the area of the triangle. It's just 1/2 times the base, which is 2 plus 18, that's 20, times the height of the triangle that we just found, 6, and you get that the area of triangle ABC is equal to 60. So for this third and final one, we have a ratios problem. In the figure right here, trapezoid ABCD has midpoint M between A and D, and BC is 1/3 of AD. So that first little bit of information was telling us that basically AM is equal to MD because M is the midpoint of AD. That second little bit of information was telling us that BC is 1/3 of AD. So when that happens, you can just put x for BC and then 3x for AD, because BC is 1/3 of AD. And at this point, it doesn't matter whether x is 10 or 20 or 30, it just matters that BC is 1/3 of AD. And that's what it is, because BC is x and AD is 3x. Alright, good. Now, at this point in the problem, you might think that there's not enough information to keep going because we have no idea what these heights are. But the cool thing about this problem is that you don't need the heights. All you need to know is that there's a ratio between these three triangles. Because M is the midpoint of AD, and this is 3x, we know that this is 1.5x. And this is also 1.5x. So the original question was asking us what's the ratio between this shaded portion and the entire area of the entire trapezoid. And because the heights of these triangles are all the same, we just disregard the heights, and we say that this triangle right here has a ratio to these two other triangles of x to 1.5x. Now we can add up the x's of all these triangles, and we'll get that x, the ratio of this triangle, to the other triangles, all added together, is 4x. Because x plus 1.5x plus another 1.5x. And that's just equal to 1/4. And that answers our original question of what is the ratio of the entire, or just this triangle to the entire trapezoid. If you need further clarification or just have another SAT math problem, leave a comment. Thanks, and I'll see you next time.